Okay. So, the work you did yesterday in pairs, perhaps. So here's the first one. All right. So given the equations of the following lines, y equals 3/4 x minus 9, 3x minus 4y equals negative 4. All right. Negative 4y equals negative 3x minus 4y equals 3/4 x plus 1. I converted it from what? Standard form to slope intercept. Make sense? So you want to get them both in slope intercept form, because then you can look at the slopes. Are the lines parallel? Absolutely. All right? A double translation over a double reflection over parallel lines is a translation. Everybody good? So there it is sketched out. So everybody's good with the translation. Okay, now, the second part, Roman numeral 2. All right? Here's 3/4 x minus 9, and here's 3/4 x plus 1. Okay? You can either go from that y-intercept that way, or from that y-intercept up to that way, either one. Make sense? Doesn't matter which. All right? So, where does the 0, 1 come from? That's the y-intercept of that one. Make sense? All right? Now, that's the other line. So that's the line of the path of the point. All right? Does it also have a y-intercept of 1? Yes, and it makes what kind of angle? Right angle, because that's how we measure distances. Everybody good with that idea? So they're what? Perpendicular. So if the slope of that line is 3/4, then the slope of the other line has to be negative 4/3. Everybody good with that? And the y-intercept is 1, so that gives me this equation, negative 4/3 x plus 1. Make sense? I'm trying to find this point. Remember, that's on 3/4 x minus 9. These two should never have the same y-intercept when you set up your system tomorrow, if you get this one. So I got y equals 3/4 x minus 9, y equals negative 4/3 x plus 1. To find the x, I'm going to take the two mx plus b parts and what? Set them equal to each other. So 3/4 x minus 9 equals negative 4/3 x plus 1. What's 4 times 3? 12. So to get rid of the fractions, I multiply both sides by 12. Make sense? So multiplying that by 12 and that by 12. That's the result. 9x minus 108 equals negative 16x plus 12. Everybody good with that? I'm then going to solve it for x. I bring the negative 16 over. I get 25x. The negative 108 over, I get 120. Divide by 25, I get x equals 4.8. I take the value of x. What do I do with it? Plug it back in. Does it matter which equation? Nope. As long as you plug it back in and you get a y of 5.4. All right? So now I got to find that distance. I'm going from 0, 1 to 4.8, 5.4. How far is it from 0 over to 4.8? 4.8. How far is it? Kyle, you're going to get it taken away. You can't play with them like that. It breaks them. Okay? Thank you. Then I get 5.4. For the y coordinate when I plug it in. How far is it from 1? It shouldn't be 5.4. It should be negative 5.4. I think if I plug it in correctly. Hold on. Yeah, it's negative 5.4. My bad. All right. So my y-coordinates go from 1 to negative 5.4. How far is it from 1 down to negative 5.4? 6.4. All right. So whether I use distance formula or Pythagorean theorem, I'm doing what? 4.8 squared plus 6.4 squared. So I'm doing 4.8 squared plus 6.4 squared. And I get 64. And then what do I do for 64? The square root. What's square root of 64? 8. So the distance between the lines is 8. But remember, when we do a double reflection, the distance it travels is the distance between the lines times 2. So I got to take the 8 and multiply by 2. What's 8 times 2? So my final answer is 16. Good? The ones on the back. Oh, in terms of direction, I apologize. We're going to go through that real quick because people were confused about that. If I start down here, which is where 14 negative 1 is, right? And I'm going to go over both lines. Does it make sense? I'm going to end up somewhere up there. So that's going up and to the left. Make sense? That's all you have to do with translations. Give me an up and down, give me a left and right. All right? What's that? Magnitude is the distance it travels, so 16. All right, so with magnitude, with translations, it's a distance. With rotations, it's an angle measure. With reflections, it's a distance as well. So the only one, magnitude is distance with the exception of rotations. Rotation is the only one that's angle measure. Good? All right, the back. P, negative 210. Q, 0, 0. R, 0, 7. S, 2, 5. All right? So everybody good with those locations? All right. So A is reflected over line QR, then line QS. So they extend forever. Are those lines parallel or not parallel? Not parallel. So instead of a translation, what's that going to be? Rotation. Everybody good with that? And then remember, the magnitude is going to be the angle between the lines times 2. All right? Well, I need to figure out what that angle is. To do that, I'm going to do this because it's going to the origin. Make sense? S has coordinates 2, 5. It's not drawn to scale. So this is 2 and this is 5. So it's not drawn to scale when I sketch it, but that's okay. Everybody good with translating the coordinates to that? So 2, 5. So is the hypotenuse involved at all? No. So which trig functions it got to be when it's not hypotenuse? Tangent. So the tangent of Q equals what? 5 over 2. When I'm finding an angle, what button do I press first? Second. So second, tan, 5 divided by 2. Make sure you're in degrees. All right, it'll tell you where to round to. I'm going to round to 68.2 degrees. But I don't need that angle, do I? I need this angle in there. Correct? Those two angles always add up to 90, that are known as complementary. So to get that angle, I'm simply going to take that angle and subtract that from what? 90, and I get 21.8 degrees. I get 21.8 degrees. And again, you have to remember that the amount of rotation is that times. So I got to take that and multiply by 2. And I think I get 43.6 degrees. But remember, we're going this way. All right? So even though we're in the coordinate pair, we're going to describe it as what? Clockwise. That's the direction. So you only have to go counterclockwise when it's an ordered interval. When you're describing it like this, you can go clockwise if you'd like. Everybody good? All right, and then the last one's real quick. Given quadrilateral flub with coordinates F, L, U, and B. Give the 4 different translations that will result in F prime, L prime, U prime, B prime having a vertex on the origin. The origin, remember, is what? 0, 0. So that means I got to do the opposite of the coordinates. So if I'm looking at F38 and I want that to be on the origin, what's the opposite of positive 8? Positive 3. Negative 3. What's the opposite of positive 8? Negative 8. So that'd be T, negative 3, negative 8. L, what's the opposite of negative 4? 4. What's the opposite of positive 3? Negative 3. U, what's the opposite of negative 5? 5. What's the opposite of negative 6? 6. And then for B, what's the opposite of positive 2? Negative 2. What's the opposite of negative 2? That's all it is. So to get back to the origin, you just do a T and you do the opposite of the coordinate. All good? All right, we're ready to go for tomorrow. Woo! All right. We'll stop this.